would happen to the pile of gasoline. We can apply this to many types of the price. Let's say the stock price, the price of agricultural product, the price of gold or commodity price, and so on. We can use this basic combination. You can see that we just start with the regression model and adjust to AR model and adjust regression model to the trend model, and we recombine. We get the other type model. Many more advanced econometric methods are building from the same concept. So when you study the more advanced method, it's just from combination of the basic method. That's it. If you understand the basic concept and how to combine the method, the basic method, you can learn any advanced econometric. Okay. It's very important that for the undergraduate students to learn. Okay. Should we have only the linear trend? What is the linear trend? Suppose this is time, right? Suppose we have the variable y, 0, period, 1, 2, and so on. So when you have y0 here, so you try to predict y3. So you get y1, y2, and so on here. This is y hat. This is the linear trend, right? We get y hat t equal to beta 0 plus beta 1 times t. Some econometric textbook, they use different notation, they use this, right? You can use any. The last, they are the same, these two equations, they are the same. Because they use the notation t hat to indicate the y hat component, we have only the trend component in y hat. Right? Because there are some assumptions in here. It's the same thing. But when you write this equation, it's correct, but it's not so specific, because in order to make this equation to be specifically correct, meaning that you have to assume cycle plus a cycle equal to seasonal equal to calendar equal to 0. You have to assume this. I wouldn't say that the textbook that write the first equation they are wrong. They are right, but it's not so specific. But some other textbook write this notation more specific notation. They are the same thing. Okay. Let's look at the before I move to the nonlinear trend. I would give you some background about the nonlinear regression first, and then we will try to use the concept of nonlinear regression with the nonlinear trend model. The next topic is nonlinear regression model. There are many methods of the nonlinear regression model. but there are 4 or 5 basic nonlinear transformation. Sometimes we can transform the linear regression go back and forth with the nonlinear regression. When we move back and forth between linear regression and nonlinear regression, this group of technique is called transformation technique. Use the transformation technique. There are many transformation techniques. I will start with the first transformation technique. Is called the polynomial transformation. Polynomial first. There are many transformation techniques. Let's go to the polynomial P-order polynomial model. P-order polynomial model. What is polynomial? I think many of the students study the polynomial function in high school. What? You are familiar just only the name, right? What's the polynomial? Okay, before we move into the polynomial model, let's know something. Okay, no. Let's recall high school mathematics. Okay, okay, recall that first. Did you familiar with y equal to a plus b x plus ax squared plus bx plus c? Did you familiar with this? Ax squared plus bx plus c. In high school, it's called parabola, right? Function, right? Parabola function, right? What's the parabola function? The parabola, it is the second order polynomial function. The parabola is the second order polynomial function. How can we look at the second? How can we see that this is the second order polynomial? So you can see that it's power 2, right? The higher power is we have. In econometric, they call this is the other name is called the quadratic form. This is called the quadratic form. Quadratic form or second order polynomial function, sometimes called quadratic form. In mathematics, it's called the parabola, but in statistics, called quadratic form. The same thing. How to rewrite this? You can see that. Suppose before we transform this mathematics function into statistical function, you have to get some background first. Let's remark. You have to learn deterministic process versus stochastic process. Deterministic process and stochastic process. What is the deterministic process? When we, by definition, suppose x and y has the deterministic process, become the deterministic process. Meaning that we can tell the relationship between x and y with exact, precise relationship. If we know the exact, precise relationship between x and y, meaning that we can determine value of y. Exact, precise relationship. If we have the exact, precise relationship between x and y, if we know the value of x, we can exactly determine the value of y. The value of y. What is the example of exact precise relationship? Suppose you want to send some package in the using the EMS or mail postal service or something like that. If you go to the post office and you say that, so suppose when I'm here in Thailand, I rarely go to the post office, but when I was in the US, I went quite a lot to send something back home. For example, when you suppose y it is the fee to the postal fee, but x is the weight. Suppose we get the fee would be equal to $2 plus 0.5 cent, $0.5 or 50 cents times weight x. You can see that if we know the weight of the package that you want to send, you know the fee, right? So, if you know the value of x, you will know the value of y. Exactly know the value of y. We call this relationship as the deterministic relationship. There's no error. You can see that this equation, there's no error in this deterministic relationship. There's no error. But what is the meaning that if we have one value of x, it would lead to another value of y, right? When I explain this using the mathematical function, we have one-to-one function, right? Meaning that Suppose you have x and y. You have the value of x. You will have another set of value of y. Right? Is one-to-one function, right? Between x and y. One value of x would determine another one and one value of y. So exactly determine one value of y. But what would happen if we have many to one function? Many value of x can lead to one value of y, or one value of x can lead to many value of y. That's many to one function, right? That is the stochastic relationship, meaning that it's opposite to deterministic. Suppose you have, for example, the salary and the GPA. Suppose the student graduate from this program have the equal GPA, let's say 3.0 GPA. When you go to work, do you think you get the same salary or not? No. You can see that one value of GPA would lead to many levels of salary, right? So if income equal to beta 0 plus beta 1 GPA plus error term, you can see that when we have the error term, this error term will take care of the stochastic term. What's the stochastic? The stochastic process sometimes is called probabilistic process. We cannot explain it exactly. We have to explain it with probability. The stochastic process sometimes is called probabilistic process. How to apply deterministic process and stochastic process in business and economics? In business and in economics, we call differently. This is the statistical term. But in business, finance, and economics, when you have deterministic process, you are analyzed with certainty situation. When you have stochastic, you are talking with the risk and uncertainty situation. How to apply this statistical concept with the business and economic and finance? We are talking with certainty situation and uncertainty situation. So, which one is the more generalized form? Stochastic. Meaning that if the error term, if I rewrite it as y equal to beta 0 plus beta 1 x plus error term, suppose. If the error term go to 0, for every value of error term, so we have error for every value of error term. This stochastic process will convert to deterministic process. Right? When error term becomes 0 for every value of error term, the stochastic process will convert to deterministic process. What does it mean when error becomes 0 for every value of error term? Meaning that probability to occur equal to 1, right? It happens for certainty, right? With certainty. Meaning that the probability equal to 1. But if the probability of the situation to happen is not equal to 1, we would have the error term, right? Therefore, x cannot fully determine y. X cannot fully determine y. This is very important for forecasting. Why? If we have deterministic process, it's very easy for us to forecast, right? Because everything happens with certainty, right? It's very easy to forecast. But the more difficult forecasting method normally dealing with the probability or uncertainty, because some situation can change over time. When the situation can change over time, it's very difficult to predict the future, right? So this is the more difficult thing. But if you study, some of the students may interested in finance and you want to work for in the stock market to be analyst or broker or whatever. If you take the course in finance, more advanced course, they will say that the stock price have the stochastic process. They will say like that. What does it mean the stock price is the stochastic process? Meaning that we cannot exactly determine the price of stock market. Therefore, investors who invest in the stock, they will always associate with the risk, right? So there are some relationship between risk and return in the stock market because the stock moving in the stochastic process. But even though the finance analyst always say stochastic process, but the more statistician will say that how to reduce the error term in stochastic process to get more precise prediction with highest probability to accurately predict the stock price, right? We know that we have the risk and uncertainty. How to reduce it to get the minimum risk, right? And get the highest return. Right? The good analyst and good forecaster, they do not scare with the uncertainty. They say, okay, uncertainty is okay, but we can predict with very precise. Even though there are some probability of mistake or something like that, right? Of error, but we reduce it at the minimum level. Okay. That's the best forecasting. Reduce it to the minimum level of risk or minimize the uncertainties. Right? So this is the best decision process. So for normal analysts, they will say, do we have associated with the risk? And they stop at this step. But more advanced analysts will say that we can reduce it to the minimum level with highest probability to make accurate decision. This is the more advanced. Okay? So let's take a break for 10 minutes, and if you have any question, you ask me during the break first, and then we'll continue the